Welcome back. This is the fourth and final video for Unit 8. And we'll take a look at solving at least one problem that's got a little bit of an attitude as it relates to the notions of present value and future value and our abilities to discern the difference between an annuity, which is a series of payments, and a single payment thing, which is what we looked at together as we worked on Unit 7. So let's rock back into the PowerPoint. Let me share this with you, and we'll make some progress on our solutions. You gotta like that. The front slide says, hey, we're gonna do word problems, and everybody's cheerful as indicated by the smiley emoji. All right, so I went for the gusto. All right. Now I thought maybe a timeline would be helpful. You certainly don't have to draw one out, but I thought, you know what the heck, I'm going to use some wicked PowerPoint skills here. So all right, read it. James decides that he wants to retire in 10 years from now and he wants to head to Vegas. I don't care where he goes. That's not pertinent to the problem. I personally like Vegas, so that's where we're going. The question says, how much should he invest today so that he will be able to withdraw $50,000 at the end of each year for 25 years after he retires? Now remember, he's going to retire in 10 years, but he wants that money to last him for 25 years after he has retired. The question says, presume that he can invest money at 6% compounded annually. All right, so you notice I tried to indicate that there were two things we had to contend with for us to solve this problem. All right, so the first question mark down there, cleverly subscripted question mark number 1, seems to mean how much money has to be there 10 years from now, okay, so that he has the ability to pull out $50,000 each year for that 25-year span as he's spending his time enjoying retirement. So that, as it turns out, that's going to be our first challenge. We must find, if you will, the value of that annuity that we'll have at the beginning of his retirement plan. And then we'll turn our attention to what does he have to invest now as a one-shot investor to generate that balance that will enable him to do his retirement. So it's a two unknown attack. We turn our attention, first of all, to the part dealing with the annuity. Okay, so let's talk about that. We're finding the present value of that annuity. Now, don't get conned here. Present value means what's it worth at the beginning of the annuity set of payments. I know that the number we're talking about references a point in time 10 years in the future, but it's the beginning of that annuity that we're concerned with. So we'll pull out our formula that helps us find present value. All right, that should look familiar because we've met it in a previous video in this unit. And let's talk about the things that we need. Well, we know he wants $50,000 as his payment. We know it's going to have to run for 25 years, compounded once per year because it says compounded annually. And his interest rate per year is the full 6%. Okay, so I could have shown you 0.06 divided by 1, but it wouldn't have changed the 0.06. Values to plug in will enable us to find how much money needs to be there to start the annuity sequence, to start him being able to withdraw $50,000 each year for a span of 25 years. All right, so there's your plug-in numbers. 50 grand going in for payment. That's how much he aspires to pull out each year. The 1.06, you're going to be so proud of me on my next click. You betcha. 1.06. Yeah, I'm not averse to punching that in one shot. If you don't want to do that, you could sequence it. If you are going to put it in one shot, the parenthesis stuff's pretty significantly important. So I said, hey, like, grab your calculator, rock and roll. And we found 639,167.81 to be the amount of money that would have to be there in 10 years for him to start that annuity sequence wherein he's going to withdraw $50,000 every year for a span of 25 years. So we have found question mark number 1. Okay, so when he's all ready to retire, that's how much money has to be there to afford him that retirement set at $50,000 per year for each of the next year over 25 years. So now what we got to do is realize that that represents a future value for what he currently needs to invest that will help create that or build that. Now, it's important that we reference the second question mark. That's a single investment. That's not an annuity. The question says, how much does he have to invest today? A one-shot deal, knowing that whatever that amount is, it has to grow into that $639,167.81 number at the end of 10 years. Okay? So it's a straight attack now, and we're going to go ahead and find out the present value for that investment. So future value, in the past I've used A for how much this grows into, but I modeled this one straight off the book. So the future value is the 639,000 number, and we're going to be solving for P. The values for R, 0.08, and the value for N is 10. All right, so there's your future. We need 630. How much do we got to put in now? So we're isolating present value for this one-shot investment. Plug in. Understand that if we're going to solve for P, we're going to have to divide by 1.06 to the 10th. That's not actually too horrible to calculate. And you'll find that if you do it successfully, for him to set up that retirement scheme that he wishes, he would have to currently deposit $356,907.97. And that would set it up so that in 10 years, he would have the full amount of $639,167.81 that would enable him to pull out 50 grand a year and would let him do it for a span of 25 years. So it's a two-part problem. All right, we found the present value of the annuity. Then we realized that that's a future value for a one-shot investment, and we needed to find the present value of that. A lot going on. It's a good problem, though. That's a good problem. Example 7, how much must you invest today to receive a $20,000 annuity for 10 years, semi-annually at 10% annual rate? All withdrawals will be made at the end of each period. All right, so we want the present value. And you want to set up a $20,000 annuity that'll span 10 years, and you're going to pull out $20,000 twice a year, semi-annually at a 10% annual rate. Some numbers for you. The payment's going to be 20 grand. Okay. And the number of compounding periods is the 10 years times 2 for 20. 2 in terms of compoundings per year because of the semi-annually. The interest per compounding period, 10% cut by 2, 5% per compounding period. Straight plug in. We're finding the present value. So in a sense, we're doing what we did on our previous problem. That was the question mark number 1, right? Calculating the present value of this annuity. So there again, I did a really good job adding 1 and 0.05. I know you're thrilled. All right, straight plug in. You'd have to invest $249,244.21. And that would enable you to pull 20 grand out every 6 months for a span of 10 years. So you found your present value. That's what you'd have to invest. The last topic for us in this unit is the idea of sinking funds. And we're finding a periodic payment referencing a sinking fund. So I'll let you read the screen. We're going to talk about, sometimes you need to create a certain amount of money so that you set it aside for repairs or for, upgrades to your facilities. So we're going to look at how compounding interest helps us in these contexts. Okay. Formula for us to find the payment of a sinking fund. So this is a new one. All right. We have a future value of an ordinary annuity times I. We're familiar with I from before. All right. So we're familiar with N from before. So in those contexts that we've been using in this section, in this unit, be sensitive to the fact that I represents interest earned per compounding period, and N represents total number of compounding periods. So here's an example for us. Smith Company's going to need $80,000 20 years from today. The interest rate 10% compounded annually. What payment must they make at the end of each year? Okay, so there's a formula. And here's what we know. We know we need $80,000. That's the future value of this ordinary annuity at some point in the future, specifically 20 years from now. That's how much they need. So that is a future value of that annuity. And what also, well, we know it's an interest rate of 10%. And since we're compounding annually, we don't really have an N value to help us do a heck of a lot. It's 20 times 1. All right, we're compounding once a year, and the interest is 0.10 over 1, which is still 0.10. So it's a straight plug. You're going 80,000 in for the future value of your ordinary annuity. You're going 0.10 in for the I value. You're putting in 1 plus 0.10 to the 20th and subtracting 1. Again, you're so proud of me because I'm really good at adding 1 and 0.10. Straight shot calculate, make sure you're good there. Group the entire numerator and group the entire denominator. If you're going to do it in a one-shot deal, you need parenthesis around your whole numerator, particularly parenthesis around your entire denominator. You could survive without them around the numerator. I still think it's a good idea. So what that means is every where the payment amount comes of $1,396.77. So that's how much, all right, for them to get the 80 grand at the end of 20 years. They would have to make that payment each of the 20 years, $1,396.77. So that's a sinking fund set up for us as example number 8. Okay, again, if you got intimidated by that calculations, the thing that's most significant on that problem is that your denominator be grouped. If you want a punch sequence, there it is. Again, for safety's sake, I tend to group the numerator, and I also tend to group the denominator. And that just makes me sleep better at night. That ends us on Unit 8. I got some problems for you from the textbook. You can find them on page 550, headed over towards 554. There's a lot going on. Those formulas are clunky. You're going to need to practice them. Again, you don't need to memorize the formulas. You have full access to them. And if it were an in-class test situation, I would give you the formulas as a separate sheet. So you simply need to know how to apply them and when to apply them. We'll be back soon for video sequences for unit number 8, or I'm sorry, for unit number 9. We'll see you then.